This is Mrs. Zappia with Lesson 22, Solving Equations Using Algebra, from Module 2, 7th grade. This is on page 130 in your book. In this lesson, you will transition from solving equations using tape diagrams to solving equations algebraically by making 0 using the additive inverse and making 1 using the multiplicative inverse. Justify your work by identifying which algebraic property you used for each step in solving the problems. Explain your work by writing out how you solve the problem, how you solve the equations step by step, and relate each step to those you used in the tape diagram. Copy the essential question. What is the purpose of making 0 with a constant and making 1 with the coefficient? In example 1, Yoshiro has a new puppy. She decides to create an enclosure for her puppy in the backyard. The enclosure is in the shape of a hexagon. So let's highlight important information as we go through the problem. It will be in the shape of a hexagon, which is a 6-sided polygon, with one pair of opposite sides running the same distance. So we have a pair of opposite sides running the same distance along the length of 2 parallel flower beds. And that's important because we know that those 2 sides of the fence are going to be parallel to each other. They might look something like this. We don't know how long they are, but we know that they are parallel and the same length. There are 2 boundaries at the end of the flower beds that are 10 feet and 12 feet. So one end of the flower beds, so let's say that's over here, and so let's make that one 10 feet and this one 12 feet. And I don't know that that's exactly right, but I know that the 12 feet is a little bit longer than the 12 foot. Then, respectively, at the other end, the 2 boundaries are 15 feet and 20 feet. And this needs to be 6-sided, so the other 2 sides will have 15 feet, and then the other side's going to be a little bit longer, 20 feet. The perimeter of the enclosure is 137 feet. What is the length of each side that runs along the flower beds? So we have the flower beds. Let's make those red. So the flower beds are right here, and that's what we want to know. How long is that side? So it is in the shape of a hexagon, and generally you're used to seeing a hexagon that would look like this with 6 sides. And that's a regular hexagon where all of the sides are the same length, but clearly these are not all the same length. So now let's label all of the side lengths. This one was 10 feet, and this is 12 feet. And 15 feet and 20 feet. And the question is asking us, what is the length of each side that runs along the flower bed? So when we don't know what it is, we use a variable for that. So we'll call that x. And then we know that this other side is the same length, so we can call that x as well. We know that the entire enclosure has a perimeter of 137 feet. So we can write an equation to solve this problem, since we know that what it is equal to. And we're going to solve this problem in 2 ways. We're going to use a tape diagram as well as an equation. So first let's start with our equation. We set up an expression that represents the perimeter, and we know that all of these numbers need to be added together. So I'm going to just start with my variables first, x plus x, and then I'm just going to list the other ones in order, 10 plus 12 plus 15 plus 20. And all of that expression adds up to and equals 136, or 137. So now we have an equation that we can use to solve that problem. Also, we're going to make a tape diagram for this. We know that the total is 137, so we'll go ahead and we'll make our diagram with an empty box for the x, another empty box for that x, and then the other ones we know how much they are. So this part of the fence is 10, this part of the fence is 12 feet, the next part of the fence is 15 feet, and the next part of the fence is 20 feet. And I didn't know how big to make these boxes, but I do know they do need to be the same size. And all of this represents 137 feet. So the first thing that I want to do is figure out how much of the feet is already being used up on the other sides of the fence. So I'm going to go ahead and add those together. So 10 plus 12 plus 15 plus 20. And that equals 57 feet. So this part of the bar equals 57 feet. And the rest of the feet are split up between the other side. So the whole fence is 137 feet, and then 57 feet makes up all of this. So then we need to know, well, how many feet are left over? To figure that out, we subtract 137, take away 57 feet. And that equals 80 feet that are left over for the other part of the fence. So this represents 80 feet. They are the same length, so you want to split that evenly between 80. And to split something evenly in mathematics, we divide. So we're going to divide 80 by 2. 80 divided by 2 equals 40. And that means that each of these is worth 40 feet of fencing. So this is 40 feet, and this is 40 feet. Now let's check and see if we've answered the question. The question is asking, the perimeter of the enclosure is 137 feet. What is the length of each side? So the length of each side is 40 feet. Now, the purpose of this assignment is to relate what we know about tape diagrams and start to solve things algebraically. So let's take a look at our equation and what we did to solve the problem. Here, the first thing that we did was we added all of these constants together. So we'll do the same thing with our equation and add those numbers together. And that equaled 57 feet. So I'm just going to bring down the rest of the problem. And then the next thing I want to do here is I want to combine my like terms. And that is just saying how much is left over for those numbers. So x plus x is equal to 2x. Because remember that addition, repeated addition is multiplication. So if we're adding x together twice, that means 2 times x. Bring down the 57 equals 137. So this is the 2x right over here, plus the 57 equals 137. Then the next thing that we did was to subtract the 57. And when we do that we're solving an equation, you have to do the same thing with the same number on both sides of the equation. And when I say the same thing, I mean the same operation. So we are subtracting. We're going to do that on both sides of the equation. And then we are going to use the same number, 57. When I say on both sides of the equation, you could draw a wall down the equal sign here and keep it balanced, because remember that equal means the left side represents the same amount as the right side. So that's what I mean on the same side. Then the next thing, we subtract 57, and on the right side of the equation that gave us 80. There's your 80 right here. And then over here, 57 minus 57 is 0, and 2x plus 0 equals 2x. So what we're doing when we're subtracting that amount is we're saying we aren't going to look at that part of the problem anymore. We're only going to focus on this 2x and see what that is equal to. And we see that 2x is equal to 80. And that's what we have right here. The next thing that we did is that we took that 80 and we split it in half. We divided it by 2. So here's the 2. We're going to divide both sides of the equation by 2. This is the division property of equality that says if you divide both sides of the equation by the same number, the equation remains equal. So the reason I'm dividing by 2 is because we have 2 boxes that are the same. A number divided by itself equals 1, and 1 times x equals x. And 80 divided by 2 equals 40. And that was the answer that we came up with when we did the tape diagram. In the objectives, we talked about making zeros and ones. And here's where we're doing that. Right here, when you subtract the constant from one side of the equation, the purpose of that is to get a 0. And why you want to do that is so that you can isolate your term that has the variable. And we do that either using addition or subtraction. Then the next thing that we did in order to get the 1 is that we divided. So when you're getting a 1, you're either going to use multiplication or division. And the purpose for getting a 1 is to isolate the variable, to find out what one of the variables is worth. Because here we know that 2 of these equal 80, but to answer the question, we have to know what one of them is worth. Again, looking at the picture, we know that 2 of these equal 80, but the question is asking what is the length of one of them? So we need to separate that into 2 parts. So that goes over why we make zeros and ones when we're solving equations. The last thing that I want to talk about before we go on to the next page is PEMDAS. And you're familiar with PEMDAS. PEMDAS is what we use to simplify equations or to evaluate expressions. So when you're simplifying, you're following PEMDAS from left to right. And that's what we did in our first step here, where we combined our like terms. We added all of those together right here. And then we also added our like terms, which are variables. And that was simplifying the equation before we get started solving it. So the O is what's new in PEMDAS. Now it's PEMDAS. And we use the O when we want to solve the equation. And that means going in the opposite direction, doing the opposite operation. So in the opposite direction means we have to undo addition and subtraction first. And that's why we undid this addition with subtraction. Then here where we had 2x, we are undoing multiplication and division. 2x means to multiply 2 times x. So you do the opposite operation, and that was to divide. So again, when you're ready to solve the equation, you're going in the opposite direction, doing the opposite operation, undoing addition and subtraction first. So we undo this addition first, then we undo any multiplication and division. In future years, you will continue on PEMDAS and you'll be working with PEMDAS, or with the exponents, but not this year. For example 2, swim practice. Jenny is on the local swim team for the summer and has swim practice 4 days a week. The schedule is the same each day. The team swims in the morning and then again for 2 hours in the evening. She swims a total of 12 hours per week. How long does she swim each morning? So let's go ahead. We're going to solve this using a bar diagram as well as an equation. And we know that she swims a total of 12 hours per week. And we know that she swims for 4 days. So let's split her week up into 4 equal days using 3 bars. And each one of these bars represents 1 day. And in that day, she swims for a certain amount of time in the morning, which we don't know, and then 2 hours in the evening. So let's break this up here. This will be 1 day, another day, another day, and another day. And then in each day, we split that up between the morning and the evening. So we have morning, which was unknown, and the evening, which is 2 hours. And again, we have the morning, which is unknown, and then 2 hours in the evening. The morning, which is unknown, and 2 hours in the evening. The morning, which is unknown, and 2 hours in the evening. And we know that that total represents 12 hours. So the next thing that I want to do is I want to figure out how many of the hours in the 12-hour week are for the afternoon. So I'm going to reorganize my bar and put all the mornings together and then all of the evening together. So it needs to be the same length. And then we'll have morning, 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 2 hours, 2 hours, 2 hours, and 2 hours. So I'm just going to reorganize this. Mornings, and then 2 hours, and those are the evening. Then out of the 12 hours, how many of those hours are the evening hours? So I'm going to add those together. So 2, 4, 6, 8. So we have 8 hours that are represented by the evening swim practice. What's left is what she practiced in the morning. So we'll figure out what's left. So think about how do you find the difference between the total and the evening is that you subtract. So we have for this section right here, that would be 12 hours, take away 8 hours equals 4 hours. So now we know that the morning takes up 4 hours of the weekly practice. Now those 4 hours need to be split up evenly among the 4 days. So 4 hours divided by 4 days is going to give us our answer. 4 hours divided by 4 days equals 1. 1 what? 1 hour per morning. Now let's solve the equation, or now let's write an equation and solve it. So the 4 days per week, and on each day she practiced in the morning and the afternoon. So the morning practice was unknown, and the evening is 2 hours. So inside the parentheses, this is how much she practiced per day. A certain amount of time in the morning plus 2 hours in the evening. The 4 represents the 4 days. So if we had 4 times the quantity, m plus 2, that's going to equal the total amount of practice, which is 12 hours. So there's writing our equation. This is the m plus 2, and we have 4 groups of m plus 2. Then the next thing that I did is I reorganized it to find out how many m's I have and how many 2's I have. And that's the distributive property. I have 4 groups of morning practice, and I have 4 groups of evening practice. And that equaled the 12-hour total. The next thing that I did is that I multiplied the 4 times 2, and that gave me 8 hours for the evening practice. So I'm just bringing down the rest of the equation. Next, I subtracted the 8 hours to find out how many hours were practiced in the morning. And 12 minus 8 is the 4 hours. So that's right here. And then the next thing that I did, now the positive 8 and the negative 8, that equals 0. And 0 plus 4m equals 4m. So this 4m minus 4 has me focusing, or 4m equals 4 has me focusing on this section of the tape diagram, where I'm going to split up the 4 hours between the 4 sections. So I'm going to divide that by the 4 sections, divide it. Remember, you do the same operation with the same number so that your equation remains equal. A number divided by itself is 1, and 1 times m is m. On the right side of the equation, 4 divided by 4 equals 1. And that means that m equals 1, and m represents the amount of hours for one morning of practice. Okay, so we have 1 hour per morning of practice. The steps that we use to solve that problem. So we have PEMDAS that you already are familiar with, and that is for simplifying the equation. So that's what we were doing here when we distributed the 4 days to find out how many mornings and how many hours in the evening. Then the next thing that we did was we simplified 4 times 2, and that gave us 8. So at this point, we are done with any simplifying, and we are ready to solve the equation. And that's when we kick in PEMDASO. And that is to go in the opposite direction, doing the opposite operation. So here we undo addition and subtraction. And we have addition, so we're going to undo that using the opposite operation, which is subtraction. Do the same operation with the same number on both sides of the equation so that it remains equal. This is the subtraction property of equality. Then we simplify, and we had 4m minus 4, or 4m equals 4. Then we undo any multiplication and division. So here we have multiplication, we undo that with division. We show division with a fraction bar, and we divide by the coefficient 4. So that is this step right here. And then that gives us 1 times m, which is m. So again, here is where we focused on getting a 0 with the constant, and then this step is getting a 1 with the variable. The purpose of getting 0 is to isolate just your variables, and then the purpose of getting 1 is to figure out how much one of those variables is worth. I'd like you to pause the video and solve this problem algebraically and show your work step by step. When you're done, resume the video to check your work. So you should have gotten 3 for an answer. And if you did not show your work in the same way, would you please do that on the side here so that you're learning to show your work in the correct way. We're going to go down to Clara's mom, the next problem. Clara's mom found a very good price on a large computer monitor. She paid $325 for the monitor. That was $65 more than half the original price. What was the original price? So the important information is that she paid $325 for the monitor, and that was $65 more than half the original price. And we don't know the original price, so we're going to use a variable for the original price. So here's what we know. It's half the price plus $65 equals $325. This is the total for the monitor, and it says it's 65 more than half the original price. So this is the 65 more than, and this is half of the original price. Now we don't know the original price, so let's use a P for price. So now our equation is 1/2 P plus 65 equals 325. If you feel like you know how to solve this problem, go ahead and try it and then resume the video. Otherwise, we'll solve it together. So remember PEMDAS. Let's check and see if there's anything that we can simplify before we start to solve. These are unlike terms, so we cannot add them together. So no, there's nothing that we can do to simplify. So we're going to go in the opposite direction now, undoing any addition or subtraction first. So here we have addition, and we are going to go ahead and do the opposite, which is to subtract. We're going to subtract 65 so that we get a 0 pair with our constant. You have to do the same thing with the same number on the other side of the equal sign. This is going to equal a 0 pair, and 1/2 P plus 0 is 1/2 P. So go ahead and bring that down. Then 325 minus 65 is $260. Then our next step is to undo any multiplication and division. So 1/2 P, that means multiply. The opposite of multiplying is dividing. So we're going to divide both sides by 1/2 P. So I'm just going to write that on the side over here, what we're doing. We're going to divide by 1/2. Now if you remember that in order to divide with a fraction, you actually multiply by the reciprocal. So the reciprocal of 1/2 is 2/1. So we're going to multiply both sides of the equation by 2/1. I'm going to show that in a different color. So here we have 2/1, and this is also 2/1. You remember to do the same operation on both sides with the same number. So over here we have 2's cancel because a number divided by itself is 1. And that leaves us with 1. And 1 times P is P. Then over here, we have a whole number times a fraction. So I'm just going to go over on the side here to review that. We have 260 times 2/1. And 260 times 2/1 is the same as 260 times 2, because a number divided by itself is, or a number divided by 1 is itself. So I'm just going to write that here so you can have that step. Remember that 2/1 is equal to 2. And then we go ahead and do that multiplication and we get $520. So what that means when you have P, it says what was the original price. So the original price is $520. The steps that we did to solve that problem. First, we wrote the equation. Half of the price plus $65 is $325. The focus of this lesson is to learn how to solve the equations. So remember to go through PEMDAS first to simplify, and then PEMDASO, the O means to go in the opposite direction, doing the opposite operation. So we check to see if there's any addition and subtraction, and we take care of that first. Then we take care of undoing any multiplication or division, and we use the opposite operation. I'd like you to pause the video and try this problem on your own, and then resume the video to check your work. So we write the equation, and the first step is to distribute the 2 to both of those numbers. And that means we need 2 groups of x plus 2 groups of 4. Then we simplify this. 2 times x is 2x, and 2 times 4 is 8. Here we're ready to solve the equation, so we undo any addition or subtraction first. We have addition to undo, so we subtract 8 from both sides of the equation, and that leaves us with 10. Bring down the 2x, because this equals a 0 pair, and 2x plus 0 is 2x. Then at this point, we have 2x equals 10. We undo any multiplication or division. So we have multiplication, we use the opposite operation, which is to divide. Then when we do this division, 2 divided by 2 equals 1, and 1 times x is x. And 10 divided by 2 is 5, and so the answer is 5. We could also check to make sure that's right by putting it back into the equation to see if it works. So here, 5 plus 4 is 9, and 2 groups of 9 is 18. So we have 18 on the left side of the equation and 18 on the right side of the equation. So we have proven that the correct answer is 5. We're going to skip this next question and go on to the lesson summary. In this lesson, you have learned tape diagrams can be used to model and identify the sequence of operations to find a solution algebraically. The goal in solving equations algebraically is to isolate the variable. The process of doing this requires undoing addition or subtraction to obtain 0, and undoing multiplication or division to obtain a 1. The additive inverse and the multiplicative inverse properties are applied to get the 0, which is the additive identity, and the 1, which uses the multiplicative identity. The addition and multiplication properties of equality are applied because in an equation A equals B, when a number is added or multiplied to both sides, the resulting sum or product remains equal.